In this lecture here, we want to start chapter 1 talking about equations and inequalities. And one of the first things we want to do is start in section 1.1 and just talk about graphs. So this is going to be talking about how you graph equations in two variables. And so I'm going to show you how to do all this stuff by hand using a table of values, which I think is really important because it'll really help you understand the process of graphing and not just jumping right to your graphing calculator to see what the graphs look like. But it'll really help you too when you move into higher level math courses, kind of understanding how you go about finding a graph by hand. And also when you start doing graphs by hand, you really get a good idea of what these relationships, these equations in two variables look like. All right, so our objectives here. So we're going to talk about how you plot points in the rectangular coordinate system. I'm going to go through that pretty quickly. We're going to graph equations in this rectangular coordinate system, also called this Cartesian coordinate system. Then we're going to talk about when you look at a graph, how you determine intercepts. That'll be real easy. And then one of the last things I'll do is I'll just do a quick application problem for you. Okay. So first off, what is this rectangular coordinate system? So the way you make the rectangular coordinate system is you first start by drawing a horizontal line. So right here you can see is a horizontal line, okay? And then what you're going to do is you're going to draw a vertical line here. You can see that I'm drawing the vertical line here that intersects it to form right angles. So here's a right angle, right angle, right angle, right angle. This horizontal line is called the x-axis, and the vertical line is called the y-axis. Okay. The point of intersection where these two graphs intersect, all right, where the x-axis and y-axis intersect is called the origin. Okay, think of the origin as the 0 points of each axis here. So now what I want to do is I want to assign some numbers to this. Okay, so positive numbers are shown to the right of this origin and above the origin. So here you can see, here's the origin. To the right, we're going to put positive numbers, 1, 2, 3, 4, 5. And then up above, we're going to put 1, 2, 3, 4, 5. And negative numbers are shown to the left. So -1, -2, -3, -4, -5. Think of this as like a number line, right? Negative numbers, 0, positive numbers. And then negative numbers are also shown going down. -1, -2, -3, -4, -5. And what I want to do now is I want to plot numbers on the on this rectangular coordinate system, okay? So plot these points. So these points here, all right, and this is going to be referenced later on in the lecture, are plotted as ordered pairs, okay? And they're shown as the x-coordinate value first and then the y-coordinate. So to plot this point -2, 4, you're going to go along the horizontal axis to the value -2. So it's negative, so you're going to go to the left -2 spaces. And then it's saying, okay, well now go up, go to the y value 4. So you're going to go over -2, whoosh, up to 4. And there's where this point is. So let's just do another one here. Let's plot the point 3, 2. So this is my x. So I'm going to go over to x3. And then my y is 2. So I'm going to go up 2. 3, 2. All right, let's do another point or two. So let's do 4, -2. So remember, ordered pairs. This is my x, my y. So my x is saying, okay, go over to the x value 4 and then down to -2. So this is the point 4, 2. All right, let's plot this one. Let's plot -1, -3. So this is my x. So I'm going to go over to -1 on this x-axis. And this is my y. So then I'm going to go down to -3. So -1, -3. So we're going to plot a ton of points in the coming section here when we look at these graphs. Okay, graphs are the relationships of two variables. Okay, so exactly what is this relationship I'm referring to? So relationship between two quantities can be expressed as an equation in two variables, such as this one. So y is equal to 4 minus x squared. So this is an equation in two variables because I've got the variables x and y. So a solution of this equation, so a solution of an equation in two variables, again x and y, is an ordered pair of real numbers. So I was kind of hinting at that. Ordered pair is a solution, and it's shown as x comma y. Okay, so what happens here is when the x coordinate is substituted in for x in the equation and the y coordinate is substituted in the y equation, we obtain a true statement. Like let me give you an example here. One solution to this equation, okay, might be the ordered pair 0, 4. So what that means is when you plug 0 in for x and 4 in for y, so 4 is equal to 4 minus 0 squared, you get 4 minus 4. That's a true statement. So now it turns out there's actually like an infinite number of solutions to this equation. So like, let me show you another one. Another solution might be the ordered pair 1, 3. All right, so when I plug 3 in for y and 1 in for x, I get a true statement, right? So 1 squared is 1, 4 minus 1. And what we're going to do here is what a graph of this is when we start looking at the graph of this equation. So the graph is going to show basically all the solutions to this equation. It's going to show the relationship between the two variables. And so what I want to do now is I want to walk you through 1, 2, 3, 4, 5, 6 graphs, okay, and how you sketch these graphs, okay. And the way I'm going to show you how to do this is with is going to be with an ordered pair, or is with a table of values to find ordered pairs. So using a table of values. All right, so what you're going to do, all right, so you have this equation, y is equal to 2x minus 3. And maybe I have like no idea what this looks like here. So what you're going to do is you're going to set up a table of values. What you're going to do is you're going to pick the x values, and forgive my tables here, my handwriting here might not come out great, and you're going to pick those x values and you're going to plug them into the equation and get the y values, and what's going to happen is then you're going to have ordered pairs, you're going to have solutions. So what I'm going to want to do here is I'm going to want to pick some x values that are negative. So let's see what's going on this side. I'm going to pick a 0 here to see what happens when x is equal to 0 near the origin. And then I'm going to pick some positive numbers, 1 and 2. Now all you can do is you can take these and plug them in here. So it's going to be y is equal to 2 times negative 2 minus 3. Well, 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. So what's going on here is this is one solution to this equation. So if you were to plot this, and that negative 7 is actually off the axis, but you'd go negative 2, and negative 7 would probably be like right around here. Now let's do the next one. Y is equal to 2 times negative 1 minus 3. Well, 2 times minus 1 is minus 2. Minus 2 minus 3 gives me minus 5. So my next ordered pair, the next solution is minus 1 comma minus 5. So negative 1, negative 5, right there. Y is equal to 2 times 0 minus 3. Well, that's just minus 3. So my next solution is 0 minus 3. Y is equal to 2 times 1 minus 3. Well, 2 times 1 is 2 minus 3 gets me minus 1. So another ordered pair is the point 1, negative 1. And then finally, y is equal to 2 times 2 minus 3. Well, 2 times 2 is 4. 4 minus 3 is 1. So 2 comma 1. And look, you can see, look at these ordered pairs. Wow, they really show the pattern, the relationship here. So what I'm just going to do is I'm just going to draw a straight line in this case through the points. All right, and then what I'm going to do is I'm going to put arrows on the end of the line to indicate that the relationship, keeps going on and on forever here. So this right here shows the relationship between the variables x and y with this equation. Y is equal to 2x minus 3. So this right here, okay, this equations of this form, y is equal to mx plus b. where m and b are real numbers, is a linear equation. Okay, and linear equations just follow this straight line right here. That's exactly what they look like. But if you stick with this table of values, you're going to hopefully be able to see the pattern and see what this equation looks like. All right, let's do another one to see if it keeps going. So now here, sketch the graph of y is equal to x squared minus 4. Okay, so notice I got a squared term in here. So again, I'm going to use the table of values. So x, y, and I'm going to get my ordered pairs, my x comma y. So let's just pick the same values again. Let's go -2, -1, 0, 1, and 2. And what I'm going to do is I'm going to take these and I'm going to plug it in here. So y is equal to, now it's -2 squared minus 4. All right, -2 squared is 4. 4 minus 4 is 0. So I've got the solution, x value is -2 and y is 0. So let me just plot that. -2 and then 0 for y. Y is equal to -1 squared minus 4. Well, -1 squared is 1. 1 minus 4 gets me -3. So this is -1 comma -3. So -1 down to -3. Now I'm plugging in 0 in for x. So 0 squared minus 4 gets me -4. So 0 minus 4. Y is equal to 1 squared minus 4. Well, 1 squared is 1 minus 4 gets me -3. So this is 1 minus 3. Y is equal to 2 squared minus 4. Well, this is 4 minus 4 gets me 0. And now look, do you see a pattern here with the ordered pairs you got? Yes. So this, whenever you have a y is equal to and then an x squared term here, this is going to be a parabola. Okay, so this is going to be a U shape. And for this type of equation here, what you're going to do is you're going to draw smooth curves. Okay, a smooth curve through the points. All right, so watch. And forgive my, pretty terrible drawing here, but you can see the pattern here. All right. So this is the relationship here between y and x when their relationship is defined as y is equal to x squared minus 4. You get this smooth parabolic U-shaped function here. Okay. Going back, when I talked about this relationship, y is equal to 4 minus x squared. This looked close to it. This is x squared minus 4. So now let's sketch the graph of y is equal to 4 minus x squared. Okay. So again, you're going to set up a table of values. So you're going to pick your x value to get your y. So let's pick the same values here. So let's go -2, -1, 0, 1, and 2. All right, now be careful of this negative here. Okay, so this is y is equal to 4 minus, and then I'm plugging in -2 squared. Well, -2 squared is 4, right? And then 4 minus 4 gets me 0. So be very, very careful of those negatives here. Okay, so this is the point -2, 0, right there. 4 minus -1 squared. -1 squared is 1. 4 minus 1 gets me 3. So -1, 3. Let's plug in 0. Well, that's just 4. So 0, comma 4. Y is equal to 4 minus 1 squared. Well, this is just 4 minus 1 gets me 3. So 1, 3. And then y is equal to 4 minus 2 squared. Well, 2 squared is 4. 4 minus 4 gets me 0. So now look. Do you see a pattern here? Yes. No, notice the negative here is in front of the squared term. So here the leading coefficient in front of the square term was a positive value. It's 1. So it's going to be a u that opens up. And here with the negative in front of the square term, you can see the pattern is a u that opens down. Okay. So this relationship is going to look like this. All right. So we get y is equal to 4 minus x squared. And you can see that just from the table of values, right? Like I was able to use the table of values here to get enough points to be able to see the pattern, and then I'm able to sketch the graph right from that. All right, let's do this one. Y is equal to, now these bars here, this is the absolute value. All right, so y is equal to the absolute value of x minus 1. So again, we're going to use our table of values. Okay, so this is just x, comma y, and y is the absolute value of x minus 1, and this is going to get me ordered pairs. So I'm going to pick -2, -1, 0, 1, and 2. All right, so let's plug it in. Y is equal to the absolute value of -2 minus 1. Well, that's the absolute value of -3, and that just gets me 3. So it's -2, 3, right? Because an absolute value tells you the distance from 0, and so it just turns it positive. Okay, so this is going to be -2, comma 3. Let me plug in -1, so -1 minus 1 gets me -2, absolute value gets me 2. So -1, 2. Let me plug in 0, so this is 0 minus 1, well that's -1, the absolute value of -1 is 1. Y is equal to 1 minus 1, well that's 0, the absolute value of 0 is 0. So you can kind of see a pattern here, right? But now watch what happens here. This is 2 minus 1. That's 1. The absolute value of 1 is just 1. And all of a sudden, it changes. All right? So what I want to do here is I want to be sure. Okay? So what I'm going to do is I'm going to pick another value here just to see if the pattern continues. So y is equal to 3 minus 1. Well, that's 2. Absolute value of 2 is 2. So 3. Yes, the pattern continues. So the absolute value here, whenever you have to graph an absolute value, it has a V shape. So it's going to look like a straight line going straight down, then it's going to hit this turning point here, and then it's going to put up like another straight line. Okay? So it looks like a V and not a U. V-shaped here. Okay. Let's now look at this one. This one will be a little bit harder. Okay. Y is equal to x cubed. So now we're looking at the cubic. Okay. The cubic. Okay, so let's pick the same values again. -2, -1, 0, 1, and 2. Now let's just plug them in, right? So y is equal to -2 cubed. Well, -2 cubed, -2 times -2 is +4. +4 times -2 gets me -8. So this one, I'm going to go -2, and then 8 is probably way down here. Okay? That's my first point. It's off the graph. Oops, sorry. -2, 8 is down here. Sorry, my pen keeps erasing it. Y is equal to -1 cubed. Well, -1 cubed is -1. So -1, -1. 0 cubed is just 0, so it goes through the origin here. Now 1 cubed gets me 1. And then finally, 2 cubed, well, that just gets me 8. So 2 and then 8 is probably up here. And so with the cubic, again, just smooth curves through the points. So it's going to come up. And it's going to look like this. So this is my y is equal to x cubed here. All right, so you can see the relationship there. You can see the pattern here. All right, let's end now on this one. This one's a little bit more difficult here, very difficult. Sorry, let me just put this in here, 2, 8. Okay, so this is the reciprocal function. Y is equal to 1 over x. So this is a little bit more complicated. So if you look at all the previous examples, the domain, you could plug all real numbers into this, right? Like there's no x value you couldn't plug into any of these examples. Okay, but if you look here, what can you never have, right? You can never have a divide by 0. So x cannot be equal to 0. Okay, you can't plug 0 in here. For these functions, okay, for these functions, these equations, these rational equations, whenever you have this divide by 0 here, in this simple case, okay, what this means is we're going to have a vertical asymptote at x is equal to 0. Okay, and what this vertical asymptote means is I'm going to draw this dotted line up here. And what it means is the graph can never cross this dotted line, okay? What it means is the graph is going to butt up against it. So I'm going to actually approach this differently, okay? So what I want to do is I want to look at positive x values. So like what happens as your x value gets closer and closer to this vertical asymptote, okay? All right, so let me just pick these values. 4, 2, 1, 1/2, and then let's just try like 1/10 here. Okay, just so you can see like, well, I'm getting really close to 0. So you plug in 4, right? So this is the point 4, 1/4. You plug in 2, you get 1/2. You plug in 1, you get 1. So let me just plot these, okay? 4, 1/4 is here. 2, 1/2 is here. 1 is here. Now notice here, what would happen is if you were to pick x values that got larger and larger and larger, like if you were to pick 100, you'd get 1 over 100. So from here on, the graph is going to butt up against this x-axis, but it's never actually going to touch it. Okay, so you're going to see here on this side is it's going to come really, really close here. It's going to come real close. All right, I missed the point there, but you get the idea. That one. Now, what happens when you plug in 1/2? So y is equal to 1 over 1/2. Well, that's actually 2. So at the point 1/2, you get 2. What about 1/10? So 1 over 1/10. That's 10. So note what's going on here is as you get closer and closer and closer to 0, this graph is going to blow up like this. Whoosh. But it's going to just keep getting closer and closer and closer, but never cross it. If you were to pick the negative values, so like the same thing, let's do -4, -2, -1, -1/2, -1/10. The only difference here is it'd be the negative value here. So I'm just going to pick the x, y points. So it's just slapping on a negative. This would be -4, -1/4. This would be -2, -1/2. This would be -1, -1. This would be -1/2, comma, -2. And this would be -1/10, comma, -10. And what you would see is that the graph would look like this. It would blow up this way. So this is what the reciprocal function looks like. All right, nice smooth curves just in the first quadrant here, nice smooth curve in the third quadrant here. And in these cases, they're bounded by the x and y axis. Okay, let's now talk about intercepts. I'm just going to do this real briefly. So x and y intercepts. So the x-intercept occurs when y is equal to 0, and the y-intercept occurs when x is equal to 0. So what you're going to do is, if you have a graph like this, the x-intercept is where it crosses the x-axis. So right here, this is my x-intercept, -3, 0. Notice y is equal to 0. All right, the y-intercept here, well, where does it cross the y-axis? This is the point 0, 5. Notice at the y-intercept, x is equal to 0. So this is just how you're able to quickly look at a graph and say, oh, okay, these are the x and y intercepts. Where does the graph cross the x-axis? Y value is 0. Where does the graph cross the y-axis? X is equal to 0. All right, let's end just by talking about a quick application problem here. All right. So divorce rates are considerably higher for couples who marry in their teens, unfortunately. Okay, so the equation D is equal to 4n plus 5 models the percentage D of marriages that end in divorce. Okay, so D is the percentage of marriages that end in divorce after n years if the wife is under 18 at the time of marriage. Okay, so let's determine the percentage of marriages ending in divorce after 15 years when the wife or just one of the partners. So it doesn't even have to be the wife here. You know, it can be a partner here. Okay, so I'll change that. So when one partner is under 18 at the time of marriage. Okay. All right, so to determine the percentage of marriages ending in divorce after 15 years, okay, because that's what we wanted to find, the marriage of divorce ending after 15 years, okay, when the wife or the partner, okay, is under 18 at the time of marriage, okay, we will use this equation, okay? D is equal to 4n plus 5. So you're given the number of years. So literally what you're going to do is you're just going to take 15 and plug it into n. So you get 4 times 15 plus 5. That gets you 65. So what we're saying here is the percentage of marriages ending in divorce after 15 years when one of the partners is under 18, all right, at the time of marriage is 65%. Eeh. So what this is saying is maybe it's best to wait. All right, so here you can see the graph here, and you can use this graph to verify it. You know, if you were to plot this, you know, here n is along the horizontal axis, D is along the vertical axis. When x is equal to 15, you see you get 65. All right, class, so I hope this helped, at least going back here. You know, use these table of values. Set this up. When you have the ordered pairs, you can see the relationship very, very easily.